Next type is reducible to linear differential equation. That is the differential equation reducible to linear differential equation, or it's called Bernoulli's differential equation. So this is the A type. Actually, this is the subtype of previous type, that is the linear differential equation. It's subtype reducible to linear differential equation, or it's called Bernoulli's differential equation. And this is the type number 8. This is the last type of our this paper, that is the paper number 2, calculus, and this is the last type of the differential equation. So the question is, define Bernoulli's differential equation and explain the method to solve it or find its general solution. So the differential equation of the form dy by dx plus pxy is equal to qx y raised to n is called Bernoulli's differential equation. So what is the difference between linear differential equation and Bernoulli's differential equation? The linear differential equation is of the form dy by dx plus pxy is equal to qx. So this is the Bernoulli, the linear differential equation. What is the Bernoulli differential equation? Dy by dx plus pxy is equal to qx. Up to this, linear differential equation and Bernoulli differential equation are same. Just one extra term is multiplying y raised to n to RHS. So qx y raised to n. So n is the any integer, value of n is integer. That is, n is either 1, 2, 3, 4. If obviously if n is 0, then y raised to 0 is 1, and then then the equation is of the linear differential equation. That is, the linear differential equation is the one of the type of Bernoulli's differential equation with n is equal to 0. But here n is either odd or even, integer but odd or even. That is, the value of n is 1, 2, 3, 4, 5, or minus 1, minus 2, minus 3, minus 4. So if n is minus 2, suppose, then y raised to minus 2 means divided by y raised to n divided by y square. Suppose n is minus 2, then it is y divided by y raised to 2. So divided by y raised to 2 means y raised to minus 2. So if this is the general form of the Bernoulli's differential equation. Now why to solve this, why to discuss the method to solve the Bernoulli's differential equation. So first step is dividing by y raised to n, or multiplying by y raised to minus n, one on this side. Divided by y raised to n or multiply by y raised to minus n. So we have y raised to minus n divided by dx plus px y raised to 1 into y raised to minus n is y raised to 1 minus n. Base same addition of powers. So 1 minus n is equal to qx, and y raised to n and into y raised to minus n is y raised to 0, that is 1. And this is suppose equation number 2. Then substitute y raised to 1 minus n as v. So we have substitute this y raised to 1 minus n as v, and then its derivative is 1 minus n. Derivative differentiate both sides with respect to x. So the derivative of y raised to 1 minus n is y raised to n rule, 1 minus n, y raised to 1 minus n minus 1, that is minus n. So the derivative of x raised to n is what? X raised to n minus 1, like that. The derivative is 1 minus n, this power, 1 minus n minus 1, y raised to 1 minus n minus 1 is minus n. Dy by dx, because this term is a function of y and the derivative is with respect to x, so multiply by dy by dx is equal to dv by dx. And so y raised to minus n dy by dx is, shift this 1 minus n to RHS, so 1 divided by 1 minus 1 divided by 1 minus n into dv by dx is the value of this quantity. Substitute equation second becomes, so this value, the value of this y raised to minus n dy by dx is this 1 by 1 minus n dv by dx value, plus px v, y raised to 1 minus n, y raised to 1 minus n is v. So v is equal to px into v is equal to qx. So this equation, after this substitution, equation second becomes in this form. Then multiplying by 1 minus n throughout. So we have this multiplying by 1 minus n throughout. So we have this, and this is a linear differential equation in v and x. So what is the form? Its form dv by dx plus p1xv is equal to q1x. All right, px and qx, because due to overlapping of the notation given in the problem, the notation are px and qx. So we denote it as p1x is equal to q1x. So what is P1x? P1x is 1 minus 1 into Px, and Q1x is what? 1 minus n Qx. So this is the linear differential equation in V and X. Instead of Y and X, V and X. So what is the linear differential equation in Y and X? dy by dx plus pxy is equal to qx. So instead of y, if you write v, then we get the linear differential equation in v and x. So due to this substitution, the given differential equation, Bernoulli's differential equation, converted to linear differential equation. So after this calculation, after this substitution, the given differential equation, linear differential equation, the given Bernoulli's differential equation, which is not linear differential equation, but this equation converted to the linear differential equation. So the basic idea of the method to solve the Bernoulli's differential equation is what? Convert the Bernoulli's differential equation to linear differential equation. And then we have to solve this differential equation, so linear differential equation. And we know that in order to solve the linear differential equation, first find integrating factor. I is equal to e raised to integration. Now here the notation is P1x, not Px dx, but P1x dx, because this is the linear differential equation. So e raised to integration, P1x is 1 minus n Px dx, and its solution is, so the general solution of linear differential equation is what? The formula is yi, but instead of y, we have to write v. So vi is equal to integration qx into I. Qx, here qx is q1x. So q1x I dx plus constant. And what is q1x? 1 minus n qx, 1 minus 1 into qx. And I is e raised to integration 1 minus n px dx into dx is equal plus constant, and then resubstitute v, reput v as y raised to minus n, reput y as v as y raised to 1 minus n, not v as y raised to 1 minus n, reput v as y raised to 1 minus n. It is not y raised to minus n, v is y raised to 1 minus n. So substitute v as y raised to 1 minus n, right here 1, y raised to, the write v as y raised to 1 minus n into I write I as e raised to integration 1 minus n px dx, right at value of I, is equal to integration 1 minus n qx I means this plus constant. Okay, so this is the general solution of the given Bernoulli's differential equation. So this is the method to obtain the solution of Bernoulli's differential equation. Can you convert the Bernoulli's differential equation to linear differential equation and then find its solution? So we will solve the problems on the Bernoulli's differential equation by using the same method. That is, first we convert the given differential equation to Bernoulli's differential equation to linear differential equation by using substitution. So we had to solve the examples of Bernoulli's differential equation. We cannot use this formula as a direct solution of Bernoulli's differential equation. But how we can solve the Bernoulli's differential equation? By using the same procedure, by using this substitution y raised to 1 minus n is equal to v. We will convert the given differential equation to linear differential equation, and then we will solve the differential equation. So this is the differential equation of that type, Bernoulli's differential equation. Example is solve this differential equation. Y plus 2 dy by dx is equal to y cube x minus 1. So this is the differential equation of the type 2 dy by dx plus y is equal to x minus 1 into y cube. So first we have to identify that this is the Bernoulli's differential equation. So dividing by 2 throughout. So we have dy by dx plus 1 half y is equal to 1 half x minus 1 into y cube. And this is the Bernoulli's differential equation of the form dy by dx plus pxy. Px is this 1 by 2. Y is equal to qx. Qx is 1 half x minus 1 y raised to n. So this is the differential equation of the type dy by dx plus pxy is equal to qx. Px is this y raised to n. Obviously n is 3. And so multiplying by y raised to minus 3. So y raised to 3, here is y raised to 3. So multiplying by y raised to 1 by y raised to minus 3. or dividing by y raised to 3. So here is, if this factor is y raised to 2, then divide by y raised to 2. That is multiplying by y raised to minus 2. Suppose here is y raised to minus 3 is the term, y raised to minus 3. Then multiply by y raised to 3. Here is y raised to 3. So multiplying by y raised to minus 3. If it is, the term is y raised to minus 3, then multiplying by y raised to 3. Opposite of this negative sign, y raised to 3 means divided by y raised to 3. See, if it is y raised to minus 3, then divided by y raised to minus 3 throughout means multiplying by y raised to 3. But here is y raised to 3. So multiplying by y raised to minus 3 throughout. So what do we have? Y raised to minus 3, right? First y raised to minus 3, then write dy by dx plus 1/2, and y raised to 1 into y raised to minus 3 become y raised to minus 2. Y raised to 1 and y raised to minus 3, multiplication is y raised to 1 minus 3, that is y raised to minus 2. 1/2 x minus 1, and y raised to 3 and y raised to minus 3 become y raised to 0, that is 1. And then put y raised to minus 2 as v, y raised to minus 2 as v. So from this we take this y raised to minus 2 as v. So we have minus 2, its derivative, differentiate with respect to x, both sides. So we have minus 2, y raised to minus 2 minus 1 is minus 3 into dy by dx, because the derivative is with respect to x, is equal to dv by dx. So apply x raised to n rule, n x raised to n minus 1, minus 2 x raised to y raised to minus 2 minus 1 is minus 3 into dy by dx, because derivative is with respect to x, is equal to dv by dx. And so y raised to minus 3 dy by dx is minus 1/2 dv by dx. So substitute here y raised to minus 3 dy by dx as minus 1 by 2 dv by dx. So equation 2 becomes plus 1/2, this y raised to minus 2 is v, is equal to 1/2 x minus 1, and this is multiplying by throughout by 2, minus 2, we have dv by dx minus 1, v is equal to minus sign in bracket x minus 1. So multiplying by minus 2, and this is a linear differential equation in v and x of the form dv by dx plus pxv is equal to qx, or write p1x and q1x, or repeat again the same notation px. And what is px? Px is minus 1 and qx is minus in bracket x minus 1. So this is a linear differential equation in v and x, so of the form dv by dx plus pxv is equal to qx. And then integrating factor is what? Integrating factor of linear differential equation is e raised to integration px dx, that is integration minus 1 dx, and integration of minus 1 is with respect to x is minus x. So integrating factor is e raised to minus x, and therefore the general solution of this differential equation, linear differential equation, suppose this is equation number 3. So this is the general solution of equation number 3 is what? The vi, instead of yi we write vi is equal to integration qxi dx plus constant. So this is the formula to obtain the general solution of linear differential equation. What is the formula? yi is equal to integration qx into I dx plus c. So instead of y, we have to write v, because this is linear differential equation in v and x. So vi is equal to integration qxi dx plus c. So substitute qx as I as e raised to minus x, I as e raised to minus x, and qx as in minus x in x minus 1 in bracket, so minus x minus 1, and I as e raised to minus x. Similarly here also substitute e raised to minus x dx plus c. So v e raised to minus x dx is equal to if you absorb the minus sign, then x minus 1 become 1 minus x e raised to minus x dx, and then after multiplication in bracket we have e raised to minus x e raised to minus x, and then integration of e raised to minus x is e raised to minus x divided by minus 1, simplification of RHS, and minus x into e raised to minus x. The integration is by using part rule. X is first, e raised to minus x is second. So write in bracket, in square bracket, first, that is minus x. It is not minus x. If it is here minus x, don't write here minus x. Write x, that is first, e raised to minus integration of second means e raised to minus x integration e raised to minus x divided by minus 1, minus integration of second e raised to minus x, its integration is e raised to minus x divided by minus 1 into derivative of first, derivative of x is 1, dx plus constant. And so the simplification is this is e raised to is equal to minus e raised to divided by minus 1 means minus e raised to minus x, minus minus become plus, this minus, don't write here minus sign, just write x. So minus minus become plus x e raised to minus x, and this minus sign minus become plus, but again this divided by minus 1 means again it is minus sign. So minus minus become plus, but after this minus sign we have again minus sign, and the integration of e raised to minus x is e raised to minus x divided by minus 1 plus constant, and this minus minus become plus sign here, next step, and e raised to minus x and e raised to plus e raised to minus x get cancelled, or directly substitute v as y raised to minus 2, v is y raised to minus 2. So the last step is substitute v as y raised to minus 2. So what we have v means y raised to minus 2, e raised to minus x is equal to this y raised to minus 2, e raised to minus x is equal to minus e raised to minus x plus x e raised to minus x, and this minus minus become plus e raised to minus x dx, and it gets cancelled. So y raised to minus 2 e raised to minus x is equal to x e raised to minus x plus c. So this is the final answer of the given problem. So this is the final answer or general solution of the given differential equation. So again, this is again the same type differential equation, Bernoulli's differential equation. So we will see the remaining problems of Bernoulli's differential equation in the next lecture.